Hello, everyone. Welcome to the web seminar, SQL Capacity Planning. It's all about time and space, produced by IT Pro Today and sponsored by Idera. Please note that this web seminar will be available on demand for 12 months starting tomorrow. You will receive an email when the session is available for review. Also, if you have any questions for our speakers, please feel free to type them into the question box on the webcast console. At this time, I would like to introduce our speakers. Howard M. Cohen is a veteran of information technology industry with more than 35 years of experience as a writer, presenter, and advisor to all parts of tech industry. Doug Walsh is a senior sales engineer at Idera Software. And with that, I will hand things over to Howard.
Thank you very much, Ashley. So today's session is all about SQL capacity planning, and I'm saying that it's all about time and space. I'm Howard M. Cohen, as Ashley pointed out, and I'm here to answer two questions. The first question is, why is SQL capacity planning so important? Who cares? The second question is, what is SQL capacity planning really all about? And of course, you've already got the answer to that because we gave it to you in the title of this session. SQL capacity planning is all about time and space. Very dramatic. Okay, let's start with space. There's a lot to measure, a lot to know that will help you in your SQL capacity planning. It's important to do this because, number one, you want to make sure that everything performs well. And when there's insufficient storage, insufficient memory, insufficient processor power, all of those things can introduce latency to the point of stopping your applications dead in the water. So we want to make sure that we know what our applications are going to call for, how large our databases are going to get, and we need to make sure that we've provisioned sufficient capacity for them. The other reason that we'll add to space is that it saves costs, especially now in the day of the cloud. You only pay for what you use, or at least you only pay for what you've reserved. So if you reserve additional disk capacity that you're not using, you're paying for nothing. And nobody wants to do that. So capacity planning can indeed help you save money and lower your costs. Let's take this list apart a little bit. Let's start off with disk capacity, storage, and storage in general. We need disk capacity for our data, for our workloads. We need index storage so that when we build indices and rebuild indices, there's a place for them, for the work to be done. There are several other issues that we want to make sure we keep on top of. Which servers, for example, are using the most storage? How are they using them? How many servers do we have? And how are they performing? We also want to look at the queries themselves. Which queries are performing well? Which seem to be running extraordinarily slow? Are we creating problems for ourselves? Which are used most often? Which ones do we need to pay the most attention to? Also, we want to look at the alert history so that we know what's causing alerts. We can do some root cause analysis, drill down and understand what's causing the alert, and therefore we can stop it from happening again. Of course, all of this begins with establishment of a baseline. So we want to be sure we're able to pull out the baseline stats on everything in the network so that we know where we're starting and we can measure changes over time. Okay, so we also want to look at backup and archive storage. Now, you may think that backup and archive storage, just put a low-cost storage device in place and set up automation to back up as necessary or archive as necessary. And that's very true. Backup, archive, pretty straightforward. There's another reason, though, and that is we want to interrogate the backup data because literally every database in a SQL environment, every transaction is backed up and stored in the SQL Server history. So SQL Server history can tell you how big the backup was 2 years ago, last year, last month, last week. And all of this can help you to forecast how much bigger it's going to grow and how quickly. So the historical growth record is incredibly valuable and something that we should turn to for help in planning our capacities. As I mentioned a moment ago, okay, I'm getting a little error, but here we go. As I mentioned a moment ago, in the cloud, we're able to request disk resources, memory resources, processor resources as we need them. And so we want to make sure that our users are making those requests cost efficiently. We want to make sure they're getting everything they need without going overboard, without requesting more than they need. So we want to look at their sessions. We want to look at the statistics from each of their sessions, what they requested, what they used. We want to see the CPU statistics. Are they really using as much pure power as they say they need? We want to look at everything about the disk. You know, how much storage are they using? How much storage did they reserve? Did they release storage on time? How quickly are they getting responses to their requests? How often are they replicating databases and gobbling up double storage, triple storage? Are they managing that properly? And of course, the memory statistics. You know, are they using as much memory as they're requesting? Is there enough memory requested to support the database instances that they're supporting? Lots to know when it comes to disk capacity, memory resources, and processor resources. Of course, all of this brings us to the meat of the matter when it comes to SQL Server, which is are our databases, say that 3 times fast, are our databases properly sized? Have we provisioned and configured them properly for maximum performance? So we want to look at which of the databases really constitute the bulk of our work, which are the top talkers, which are the ones that are using resources most. We want to look at the applications that are calling to or using specific databases and whether or not they're performing efficiently. We want to look at mirroring. How many mirrors have been established and used? Are we putting them up for nothing, or do we need more? We want to look at the tables within the databases by growth. How quickly is each table growing? Are tables being modified and expanded as well as extended? We want to look at them by fragmentation. We want to look at the temp DB, which is shared by every user of a given SQL instance. So it must be kept in good working order, and we want to make sure that it is at all times. We want to look at the transactions that have taken place, and we want to make sure that availability has been consistent. Nobody's gotten themselves locked out at any given time. So we've taken a look now at space. Now we have to look at space across time. Okay, the most important time to think about, if you really consider it, is your time. As the operator of a database, as a DBA, as somebody who's responsible for the maintenance of databases and the servers they live on, you need time to monitor, manage, and maintain all of the capacities we've been talking about. You need time to make sure that everything is healthy. We talked about doing a lot of monitoring in the last few minutes. You know, where do you get the time to do that? And part of the answer has to do with the tools available to you to do it. With the right tools, this can be done quickly and efficiently. Without those tools or with less efficient tools, it can take considerably more time. Now, there is on this slide a hint to what we consider to be the best solution for gaining as much time as possible by using the most efficient and effective tools possible. Won't get into that. We'll save that for just a little bit later. In terms of capacity planning, there are many questions you need to ask. And the reason that I say that these take time is because you really never stop asking them. You need to revisit these questions on a regular basis, mainly because, as you all know, data changes constantly, especially in terms of growth. Data is growing exponentially in all of our environments, and we have to keep on re-examining the environment that we're working with. When am I going to run out of space? And it's a very important question. Unfortunately, when you answer it today, 6 months from now, that answer won't be accurate anymore. It'll probably be a shorter amount of time. And a month after that, a shorter amount of time. So you really need to keep your eye on the size of your drives, the capacity that's already been used, the size that you provision for your databases, for your various disk partitions, all of the things that must get bigger as the data gets greater. You want to talk about consolidation. One of the great things about virtualized storage and virtualized servers are that we can move VMs, we can move virtual machines from server to server depending on the space available for them. So rather than provisioning more space in certain cases, we may just move VMs very quickly from one server to another. Many of us move those VMs so we can shut servers down and conserve power. So there's every good reason to be asking which servers, which SQL instances, which databases can be consolidated, and how quickly and efficiently can we consolidate them. In terms of standing up servers or VMs, how many workloads can be mixed in the same instance? There are applications that perform perfectly well on the same VM as others. There are some that require their own environment to work in. So we need to carefully inventory that and assign applications accordingly. One word that I can say that all of you will identify with, I have no doubt, is the word bottleneck. Especially in the SQL environment, it is all too easy to create an environment in which multiple requests are being made on the same database or on the same index, and there are so many of them that the database itself, the performance, slows down, diminishes. The fortunate thing is that more often than not, we've created that. And if we examine what we've done, if we take a look at the queries that we've created, we can often find ways in which we've hobbled them ourselves. And so we need to look at where bottlenecks are occurring so we can figure out why they're occurring and then prevent them from occurring. Of course, a constant question is budgeting. In most of our environments, it's not just how much should I budget, but how much should I be prepared to fight for my budget and get the budget that I need to support what my users need from me. And then something that we're going to run into more and more frequently as applications become more and more narrowly focused, what's the most effective way to roll them out? Am I going to create a small VM and a small pilot? Am I going to roll out user group by user group, community by community, location by location? There are many things to consider, many different parameters involved, and a lot of planning needs to take place. So we need to have time to answer those questions, and we need to take the time and sequester the time on a regular basis to keep on revisiting these issues, making sure that we're constantly current. When I talked about time, when I first mentioned the word, I would bet that most of you thought about the time it takes to run a query, because that's probably the time that's most front of mind when talking about SQL. And how long it takes to run a query, of course, is a function of many different elements, including how fast does the CPU run? How efficient is it being based on the requests being made of it? How effective is the I/O that we have available to us to get data on and off the bus from core memory and then out to disk and back? The more latency in the I/O, the more latency in the query. Are we using sufficient memory? Do we need to request more? Are there issues on the network itself that are slowing down transport of data? Are we getting a high number of collisions that's causing the data flow to slow down? These, in and of themselves, each of these things may be minuscule. And how healthy is the temp DB? In and of themselves, each one may seem minuscule, but when you add them up over time, and not a great amount of time, you'll realize that the smallest improvement will translate into powerful gains in terms of the time it takes to get things done. There's also careful time. I mentioned before that we create a lot of the problems ourselves in how well we write the queries, how efficiently we write the queries. Do we take advantage of the right capabilities within SQL, or are we using the wrong capability to get the right result, just slower? But there are other blocks and locks that we create for ourselves in terms of collisions, in terms of file and record locking, in terms of all the things that can go wrong inside of a SQL database. Most prevalent, based on a lot of the conversations I've had, is the issue of paging. Have we established a large enough page size, and have we established a large enough memory size to avoid paging? Because every time you page, you're going out to disk and you're coming back. And every time you go to disk, that is slower. There's just no way around that. Unless, of course, you're using solid state memory, but that's really only just now starting to become more and more prevalent. So paging is still an issue that we really need to take a look at. It's worthwhile to spend time thinking about, looking at, measuring against where are the latencies in our network, in our processing, in our storage, in our bus. Where are the latencies occurring, and how do we go about correcting them or improving upon them? And at the end of the day, all of this translates into performance. Performance is important. How quickly things get done is not only important because we want to get things done quickly, but we also want to get things done less expensively. We want to reduce the cost of operations every way that we can. Budgets are scarce, and we need to make the best possible use of every dime. So in a very true sense, when it comes to SQL capacity planning, time equals money. So there's every good reason for us to want to be sure that we are measuring everything that can be measured. Now, you're probably thinking, that's an awful lot of measuring. What can I do to make it easier for me to measure all that? And I'm glad you asked that question, because when we're talking about time, right now, it's time for my friend Doug Walsh from Idera to tell you exactly how we're going to do it. Doug?
Yeah, thank you, Howard. And so just to highlight some things that not only Howard has mentioned, but also how, using the Diagnostic Manager can help you out in getting the information you need. Now, let's first start off with, I found this quote. I thought it was very appropriate. A good plan is like a good roadmap. It shows us the final destination and usually the best way to get there. Now, to be able to establish a good plan, we have to have a lot of good information. Now, sometimes let's say you're going to be installing a new application. They may have some recommended guidelines. Even Microsoft, they'll say, here's what's the minimum requirements that you need for a SQL Server to operate. Well, in reality, it's usually the minimum amount, and it's nowhere near what you really need to do whatever task it is that you need it to perform. So you really need some good information as far as what's going to be going on, whether it's, what is our anticipated number of transactions, what is it supporting, things like that. Also, nowadays, when we talk about VMware and these virtual machines, you have to think about at the upper level what's going on there. So there's a lot to consider. So let's talk about Diagnostic Manager and how it can help you get this information. Now, first, let's talk about the responsibilities of the DBA. And so a lot of this, will ultimately trans back into things we have to think about when we talk about capacity planning. From installation to upgrading, obviously, how much storage are we gonna need? Now, again, we may have some ideas up front. Oh, given this time frame, we might anticipate this amount of storage, and this might be information that you get from the vendor. But it's always going to depend on, well, what is going on in your environment. Whether it's, for example, we talk about monitoring and optimizing the performance of the database. Again, this is another key thing. Are we talking about queries? Are we talking about, are we doing, for example, are we using a simple or a full recovery model? If so, we're using the full, well, then we're also got to consider, that log space, things like that. Of course, planning for backup and recovery of that data information. And in fact, when we talk about backup and recovery, there's a couple of other things to think about, not just, well, what is the physical size going to be? What do I need to be able to store it? But there's also some other considerations that, for example, if I do have a downtime, there is a problem and I need to do a recovery, how much time is it going to take to do that restore? Right? And so I've worked with a lot of customers over the years that are looking at, for example, data domains and things like that. And, then the question is, are we sending the data uncompressed, which is great because then we let the data domain do its business and it really shrinks out on that data. And so we need less drive space to host it. But on the other side of it, if that data domain isn't directly on our network, and maybe we're storing it offsite or whatever it is, well, now you got to consider that when we're doing recovery, well, we're actually sending the unencrypted data, or I should say uncompressed data, back across the network to do the restore. So you got to think about, what does it mean? What are our, requirements as far as how quickly do we need to be able to get back up and running? We've talked a little bit about, that archive data, where that's going to be stored and how we manage that. And then of course, it's really what's going on with that server when we talk about, generating various reports, whether it's for queries or other things. And so we're going to show how Diagnostic Manager can really bring a lot of this information to the forefront so you can really make better decisions as far as planning out for the future. Now, capacity planning, what is that? Capacity planning is all about the process to understand, well, what is our needs? How much can we really do? And more importantly, in the context, when we say it's capacity planning, design capacity is the maximum amount of work. It says here an organization, it could be a server, it could be multiple servers, but that can be, that work that can be completed in a given amount of time. And that's very much true when we talk about SQL servers, because with SQL servers, we may have multiple servers, we may have a single server. What is it supporting? Is it the back end for the company's financials? Is it the back end for a really busy upfront web application? And what is going to be the anticipated load on each of those? Can we combine them? Things like that. What is the most that we can put on there? Certainly when we talk about things like auditing, right? When we're dealing with compliance, we've got to store all that data. And how many servers can we audit? Things like that. Now, talking about, main reasons, and some of this has already been touched on, but main reasons, why do we do capacity planning? Well, first and foremost, as mentioned before, it's to save money, right? Can we get the same amount of work done with 3 servers versus 10 servers, right? And there's a lot involved when we talk about saving money. Is it the physical boxes? Is it the amount of resources that we have to allocate to the VM host to support these servers? More importantly, when we think about licensing and what's the cost there, as well as, how much time does it take to manage 3 servers running these applications versus 10 servers, things like that. And of course, the main thing that we do want to do is mitigate the risk and reduce downtime. And of course, there's a number of ways in which we can do that. When we talk about mitigation of risk, are we going to be going to either a failover cluster or, today a lot of my customers are going to use high availability groups, right? In a way in which we can reduce that downtime. So do we need to plan for that? Of course, it is all about increasing our productivity. If we have downtime, well, then we're not going to be very productive with what's going on. So, increasing productivity can mean a couple of different things, whether it's downtime, whether it's slow performance on our servers, things like that. Last thing you want is your user sitting around because they're waiting for the server to come back with a response. Now, increased positive experience with many of my users. I've worked in tech support for many years prior to this, and, that's a big thing. When things start to go problematic, users start to get a little antsy and upset about what's going on. And when that happens, nothing ever good comes of it. So making sure that we have prepared appropriately, that we don't have those slowdowns, that things are running as they should, obviously is a way in which we can increase the positive experience for those users. And, the last one is, of course, make most efficient use of my resources, whether it's on a single server, whether it's within the VMware. And as Howard mentioned, we also now have cloud services as well, which directly relate to, how much money do you want to spend? So let's make the most effective or efficient use of all those resources that we have, just as we need to, so we can make sure that we're properly making use of those resources and they're not just sitting there costing us money but doing nothing. And that goes down to the bottom one is eliminating waste. I'm paying so much for the storage in the cloud, I don't need it, or maybe the IOPS to look, I'm paying for licenses for 10 different servers. I can eliminate some, consolidate, because I have servers that are being underutilized. Now, again, when we talk about capacity planning questions, and these are, again, Howard had already touched on, but, again, when will I run out of space? Being able to project, see historically what we've been using, planning out for the future. Something Diagnostic Manager, I'll show you how exactly we can very easily see that. Which servers or SQL databases or VMs can I consolidate? Again, what's underutilized? Where can I put stuff in? Or maybe I'm going to be installing a new application. Can I use one of my underutilized servers? What workloads can I mix together on the same instance? So when we talk about capacity, my initial thought in my head is, oh, it's storage space. But it's so much more than that. It's, what is the capacity that SQL server can support? Whether it's, of course, storage, but more importantly, what is my workload? How many queries am I going on? Or do I have a lot of sessions and other activity? Maybe I have a server that's just doing a bunch of weekend stuff, and now I'm installing an application that's just for the users. Well, obviously that stuff can overlap because they're not going to interfere with each other. Where can I expect my next bottlenecks to occur? Again, we can talk about network, we can talk about disk I/O, and that's one that you have to be really careful of. Again, when we're talking about using VMware, it's kind of a black box, and now we have we can spin up all these servers and all this kind of stuff. But when you think about it, it all funnels down to the same bit of hardware. So let's make sure we're not overutilizing those resources to where maybe I'm hitting a lot of the same disks, things like that. Again, this also moves right into, what do I need to budget for my resources, right? Again, if I can better consolidate things, maybe I can reduce the amount of resources that's needed. Again, when we talk about budget, a lot of times those are things that are out of our control. So we got to work with what we're given, and we want to make sure that we're doing that efficiently. And that goes right down to the last point. What is the most cost-effective way to roll out this new application? Do I have to spin up a new server? Can I put this information on a server that's being underutilized? Things like that. So let's talk about ways in which Diagnostic Manager can help. First, we'll just talk about the space consumption and what's going on with whether it's our disk space, whether it's the growth on our databases, or even the tables. And one of the things with Diagnostic Manager is not only can we look in what's going on today, but we have been keeping that information historically. So, for example, when we talk about, let's say, the database growth forecast, we can look at what was the database growth over the last, whether it's last 30 days, 90 days, 365 days, and now let's project it out where we may be. Let's say we looked at last year, we're going to project it out the next 3 years. Make sure that we're going to have sufficient space, and if not, what can we do to plan to mitigate and make sure that we're going to be okay in the future? When we talk about what's going on with the server, we have what we call the predictive analysis. And when we look at the predictive analysis, it's going to look a lot of different things. Not just that, hey, we've had some alerts and we can predict when those alerts may occur, but we can also look at things like, what's going on as a whole with the server? What's been going on with my memory, my indexes, databases, things like that, and make some general recommendations on what we can help you, not only for performance reasons, but also to ensure that, you're following some good practices. For example, it was telling me I hadn't been doing backups, which I hadn't been. It was all on my laptop. And so I didn't want it to give me that message anymore, and I went ahead and did backups on everything. And now it's telling me that, yes, all my backup files are on the same volume as my disk, right? Obviously, that's not good practice. I lose that disk. I'm losing not only my database backups or my databases, but I'm losing the backups too. So it's going to really help you out in a lot of different ways, not only with this, but also with looking at queries themselves and making some recommendations. For example, if you have an implicit, it detects that there's an implicit conversion going on with one of your queries. That could ultimately cause a index suppression. And again, that's going to be something performance related. That could trickle down to, well, now I've got some blocks, deadlocks going on, and it could affect other users as well. Now, when we talk about servers, one thing to note is each SQL Server in your environment is going to behave a little bit differently, whether it's the hardware configuration from the amount of core processors to the memory, but more importantly, what is it supporting? What is it doing? Again, is it a back-end server for your company's financials? Is it a busy front-end web application? Whatever it is. And when it comes to understanding and alerting what's going on with that server, we want to understand first what is normal. And we do that through what's called a baseline. And a baseline will allow us to understand what is normal for that particular server so that we can see when changes happen for it versus just the general setting that Microsoft recommendation is pretty much 75% is a warning and 90% is critical for just about all their alerts. And really, that doesn't make a lot of sense in most cases. I mean, let's talk about OS memory as an example. In most cases, let's say I have 32 gigs of memory. I say, okay, SQL Server, you can use 28 of it. You can allocate up to 28. Well, what does SQL Server do? So it says, thank you very much, and takes all 28 gigs, okay? Whether it uses it or not is irrelevant. From an OS perspective, it's been allocated. So already we're close to 90% usage on our memory, but that doesn't mean that there's a problem. But the baseline is going to let us know what is normal for that server so that we can make adjustments as we need. Next thing we're going to talk about is comparison reporting. And so we've got a lot of tools, obviously see what's going on. Another thing that we can do, though, is we can look at, we can compare. So, for example, again, using those baselines, maybe I want to see that, let's say it's a test, that's a staging environment, okay? And we want to compare that against my production. I've done an update. We can compare the two servers, see if that update that I've applied on my staging is going to have less or better performance than, let's say, what we have in production. Or, for example, maybe we've already applied a change, and we want to look and see how that change is affected since, from before and currently. So understanding that, what's changed and things like that can be really helpful. Certainly in the case when we're about to run a rollout, if all of a sudden you see really bad performance, it's probably not something that you want to go ahead and apply to your production servers. The last thing I want to talk about before I go ahead and jump and actually show you what's going on within my environment so you can see a live demo of the Diagnostic Manager is its flexibility. Again, each server is going to be a little bit different. There are going to be different requirements around them and what they perform and who they're servicing and things like that. That said, we understand that we're not out of the box going to give you 100% of everything you might be looking for. That said, we have a number of options here, whether it's something called a custom counter, where whether it's a WMI counter for the OS, for SQL, for your VM. I can also even create my own custom counters using a SQL Server script. And now I can pull back additional information that, again, might be unique to that server, and we can track it, and we can have threshold settings around it. We can also very easily create some custom reports. A couple of clicks, I can choose whatever counters I want to include on the report, including those custom counters, and now I can generate my own reports in a matter of literally seconds for whatever I want. So there's a lot of flexibility built into Diagnostic Manager as well. So let me go ahead and share my screen. I'm going to show you exactly, what's going on in my environment. Understand everything's on my laptop. So one of the things you're going to see is a lot of problems with resources. In a production environment, that would obviously raise a lot of red flags. And I'm just waiting for my screen to show here. Okay, and so right now we're just looking at a top-level view. We can see all my servers here. Let's talk about those baselines, okay? Now, a baseline is understanding what's normal for a given server. And understand that when we're trying to determine what that is, we may want to set time limits of what we're looking at. For example, I have a general business case user or server. It supports an application that's typically used Monday through Friday, let's say 7 a.m. to 6 p.m. And the rest of the time, it kind of sits around and does nothing, right? Well, if we're trying to understand what's normal for that server, we really don't want to care about when it's doing nothing. Or maybe in the middle of the night, I have a whole lot of maintenance stuff going on, or let's say it's a data dump from another server that gets updated every night, and so it gets really, really busy. Well, I may not care about so much about that performance so long as it completes. I'm more concerned with what's going on with my users and when they're using it. So, I can simply right-click on one of my servers. I can go to my configure baseline. And there's a number of options we have here. By default, we're going to use a dynamic baseline. We can say, okay, let's base this information off the last 7 days of historical data so we understand what's been normal during that last 7 days. We may want to go ahead, though, and, for example, set it to a period of time where, let's say it's the beginning of last quarter, and now we want to use that as a baseline and see how things are comparing against it today. We can even create multiple baselines. And the advantage here is maybe I have a baseline for the weekday, maybe I have a baseline for the middle of the night when those jobs are running that has the high CPU usage or whatever it is. So again, we can get an understanding of what's normal for that server. In fact, we can even go ahead and let me click on one of my servers. We also have something called a baseline visualizer. And what this will do is we can pick a metric, we can look over a period of time, and we can get an idea of, what has been normal for that particular baseline. So let's say, for example, I'm going to look at, let's look at SQL CPU usage. We'll go ahead and look at the last 3 weeks, and now we can see, what's been going on with my CPU usage over that course of time. Now, this is just one way in which we can look at this data. Of course, we have reports, we have our graphs, there's a number of things, but this is going to help us understand, what's been going on with this server. Obviously, if I'm trying to consolidate servers, I've got a server with either a very high CPU usage, things like that. That may not be a server that I want to move things to. Again, if I have one that's very low here, maybe that's one I need to consolidate and put that information somewhere else. Talking about reports, if we go to reports, we've got a number of reports here. Here's one that I ran earlier, which was just for what has been my disk usage. And so I'm looking at, in this case, for both my disks for over the last 30 days. And let's project it out the next 90 days as an example. And so I can make sure that what is going to be my disk usage. I could even include the available disk space in this case. And it does have both my drives here. So you can see, over the next 90 days, I'm kind of creeping up on, what I have available for this disk. This other one looks pretty flat. That's probably my C drive, sure enough. I tried to avoid putting stuff there. So that stays flatline, but you can see I have a lot going on with my other disks. So now I got to understand what's going on there. In fact, I actually had a problem with one of my servers, this one here, and I didn't understand why I kept filling up my D drive, and I thought it was always the log space, okay? And so what I did is came over to my databases, and this is a great view, by the way. It's a one look at all my databases, how this space is being used, whether it's the data in the MDF file, whether it's indexes, the log, all that kind of stuff, as well as, backup information, just one great view on everything. And by the way, all our tabular data, you can order it by any columns. You can right-click, you can export it to Excel, whatever you want. In this case, what I did is I said, all right, show me at the top of the list, the ones with the biggest amount or using the most amount of space. And so I highlighted these four to put them in this graph down below. And what was interesting is this was kind of eye-opening to me that my biggest database, which is, let's see, the secure one, you can see here, let me order it by, sorry, I had by table size. Here we go, by database size. It's almost 30 gigs in size, right? Which, again, on my laptop, my VMs are kind of small, and I don't have a lot of room. And then look what I discovered, that this SQL Secure database, it's only using 14% of the actual size. So one thing I'll definitely be doing later today is I'm going to be shrinking that database so that I have more room on my drive that I need. And so this is just one way in which we can utilize some of this data to understand, hey, where can we make improvements? Where can we make some savings? Other reports that I want to talk about, again, when we talk about how busy or how efficient a server is. One is maybe we're trying to figure out where to move things to, what servers are underutilized, which are not, or which are overutilized. And so certainly in larger environments, this top servers report is really helpful. Now we can do it by tag. A tag is just a label. Maybe I've excluded, in this case, my development from my production. I only have a couple of servers, so I'll leave them all. But let me go ahead and let's look at the report over, let's just say the last 7 days. And, again, I could even say, let's do all my servers. Let's say if I had 100, I could have 100 on here. But what it's going to do is it's going to list my servers by, first by here's the servers with the most active alerts. Okay, and that could be an indication that, is this something I need to focus on? Do I have a lot of problems with these top servers? Is there something I need to fix? More importantly, we have things like top servers by the slowest response time. So these are usually servers that are more active, so it's going to take longer before you get a response to your query. And that's even before we've started talking about query performance and do we have query weights? Do we have server weights? Things like that going on. Of course, top servers by CPU, memory usage, and disk usage. Now, I know one of the things we talked about a little bit ago was, for example, memory. And so it's one of those metrics that you just can't rely on any one particular metric to make a determination, hey, do I need to add more memory? And again, this goes back to, how do we best manage our resources, okay? And so, for example, and this is actually kind of odd from what I see with my customers. I've got a strip that shows how much is actually in use, how much is being used by or what's allocated to SQL Server. Mine's dynamic. And then, of course, how much is SQL actually using. This is rare because usually what I see is a little strip of orange at the top, and then every bit that's allocated is in use, okay? That doesn't mean we have to go run out and add more memory, right? You got to look at other things. As we talked about before, paging. Paging is not really a good thing to have going on. Every time I'm paging, it means I'm having to hit disk, okay? And we really want to avoid that as much as possible. A little bit better when we talk about solid-state drives, but when we talk about, again, with VMs, they are probably have a lot of storage. It gets really expensive to use all those as solid-state drives, so we're probably got a lot of SCSI drives in various configurations, and so we really want to avoid that. Same thing, though, and here's what I'm more important or concerned with is my page life expectancy. If I keep losing my page life expectancy, it means I'm having to go to disk, I'm having to refresh. And again, this is going to cause less performance. So if every bit I have allocated is in use, I have some paging going on, but more importantly, just throughout the day or throughout the week, for whatever reason, I lose my page life expectancy. Okay, that's an indication that maybe I need to think about increasing resource, not just because every bit that's allocated is in use. So again, the point I want to make here is in a lot of cases, you can't just rely on an individual metric to make a determination of whether or not we need to add resources, right? And so another last thing I do want to show you, or two last things. One is, what about those metrics that we don't have natively? Now, just to show you all the different things we do capture, if I go to configure alerts, you're going to see there's all sorts of metrics here that we natively capture, from what's going on with the SQL Server, what's going on within your OS, what's going on even within the virtual machine as well. And so each of these, like I said, most of them will have a default setting of 75 is 90. We can adjust what we want to alert on, things like that. We may even have some recommendations. And so in this case, you can see, for example, if I look at my SQL CPU usage, well, I'm pretty pegged here. Okay, and so that this blue bar here represents what I typically see. What is my baseline? And right now, my baseline is hitting 100% a lot, and that's obviously a concern. I also don't want to be putting any more applications or other things on the server until first I can resolve this and then make a determination if do we really want to put something else over there. But let's talk about custom alerts. And so if I come to administration, I have what we call custom counters. And we can do custom counters in a number of different ways. And this is all for things outside that Diagnostic Manager natively captures. For example, I had a customer ask me that, hey, their SQL Server service was not running. and that causes problems. I can't run the reports and things like that. How can we alert that it's not online? And so this goes back to, again, efficiency. The user can't get the reports. Now they're waiting. While they're waiting, they're probably not being productive, right, because they're complaining that they can't get the report, things like that. So since it's not something part of the database engine that we don't monitor natively, we can certainly do it through a custom counter. And so what I've done here is I have a custom counter here just to check if the SSRS service is running. And so it's using a WMI call, specifically under the Win32 service. It's looking for the counters just started, and the name is actually references. If you right-click on that service and do properties, that would be the name. And so now whenever that service isn't running, guess what? I can send out an email alert notification. And this all goes back to saving your time, right? Getting alerted on things when there's a problem before your customers or your users start calling you saying, hey, I can't run my reports. You already know about it. As soon as it happens, we take care of it. Hopefully you don't even hear from the customer, or they're on the phone with you and you can say, yep, I'm already looking on it. It should be resolved shortly, whatever it is. We can also create a custom counter using a script. And the advantage here is obviously you can do some simple things as what I've done here. This is just, hey, I'm just going to do a count of my sales row. But now I can plot it. I can keep historical information about, how it's been growing or declining. I can have alerts around it. But let me give you another example is, let's say there's certain data conditions going on within your environment. And you periodically have to do checks for it. Well, we could actually have a simple Boolean type routine running that looks for what's the condition of my data versus whether it's, the inside the data, like these tables, certain values are matching or they're mismatched, whatever it is. Now we can return a 0 if everything's good, 1 if there's like a warning condition, 2 if it's critical. And again, now we can get alerted and notified on it, take care of it before our customers start to call. Okay, and with that, we can build all sorts of custom reports. I've talked about this before. We have a lot of great built-in reports here, from the top queries, everything from resources to database, you name it, we've got a lot of reports here. But let's say, for example, I've created a custom counter and I want to build a report based on my custom counter. Well, I can certainly do that. And it's just a couple of steps. I'll go ahead and go to my custom. I'll say I'm creating a new, let's just call it sales size, whatever it is. I click next, and then what is it that I'm going to include here? In this case, I'm looking specifically for my custom counters. In this case, it's my sales row. And we can do custom reports, whether it's individual data like this. We can also do worst performing, where you're going to look across several servers and given a metric, and again, we can set what is considered good or low as far as the values go. And then we can say, just like I showed you that top servers report, here are the worst performing servers. And so that's all it took to create that report. Now I can look at my server here. I can look the time period that I want to run. And now I can have that graph that shows me. And as you can see, I've been trying to cut down on some of the data. So I ran a whole lot of delete statements, and well, now we're creeping back up again. But we have all that data to support the rows. So again, this is, a lot of things I'm showing you have to do with not only performance and what's going on with your server, has to do with, how we can plan for the future, how we can consolidate. And ultimately, this is all about, again, saving time and money at the end of the day. So at this time, I guess we can go ahead and open it up for any questions.
All right, great, thank you. As a reminder, if anyone does have any questions, please type them into the webcast console. We have quite a few already coming in, so let's go ahead and get started. How much memory do we need, and is it cost effective? Thanks.
I'll go ahead and start with that. The question there is, when we talk about how much memory, it goes back to what are we going to be doing with that server? What is it supporting? How many transactions are we going to be processing? And that's where, I like to use, of course, my tool, the Diagnostic Manager here, so I can see, have I over allocated, the amount of memory that maybe it's being used. Of course, if you're going with a specific application that SQL Server is going to be supporting, you want to check with them to see if they have any, recommendations as far as memory and things like that. You just have to be careful when they say things like, here's the minimum requirements, right? Microsoft will give you minimum requirements, and I think it's like, yeah, you just need a gig of memory. In reality, for any busy SQL server, that's not even close to being nearly enough to what you're going to need to, be able to properly, perform in your production environment. Howard, did you want to add to that?
No, I really have nothing to add to that.
Okay.
All right, great. Thank you. Next question. Can Diagnostic Manager be used to evaluate performance for SharePoint servers or Power Pivot servers?
So the Diagnostic Manager that I showed you today is specifically for Microsoft SQL Server. Now, when we talk about SharePoint, usually a lot of that data is stored on a SQL Server, so of course we can manage performance around it, but we're not managing performance specifically around the SharePoint. When we talk about other databases, for example, let's say there's MariaDB or MongoDB, things like that. We actually now have a tool called, and it's actually it'll support MariaDB and the the MySQL. We actually do have SQL Diagnostic Manager for MySQL that's available for that as well. So something to consider. But the Diagnostic Manager that I showed you here is specifically for Microsoft SQL.
All right, and I think you touched on this question, but we'll ask it out loud anyways. Does this only integrate with Microsoft SQL? Can it be tied to things like MariaDB and MongoDB?
So with the MariaDB, that will be supported by our SQL Diagnostic Manager for MySQL. For MongoDB, we actually have some other tools. We have one that's precise, and it's actually multi-platform, so it'll support Oracle and some other ones as well, including MongoDB.
All right, great, thank you. Next question. I support Personify environments, which are comprised of 1 SQL server and 4 app servers. What benefits would I get from using Diagnostic Manager?
That's actually a great question because while those 4 applications are hitting that SQL server, if you're having performance problems, you got to understand where's the performance problem coming from, okay? And whether it's 1 app or 4 applications, we want to be able to understand what's going on. Now, let's just imagine what happens when you have a query be executed. You submit a query. Well, the first thing that goes on is, the query is waiting for SQL Server to process it. And we may have some query waits going on there. You may have some blocking, deadlocking, things like that. The query itself could be inefficient in how it's written, right? Now, the second thing to it is that now SQL Server is waiting on its resources from the OS, and you may have server waits going on. And now, of course, we have the new layer. We'll have the VMware layer, and of course, the OS is waiting on its resources from VMware, for example. VMware is just doing its best job to rob Paul to pay Peter, make sure everything's going on. And so you want to get that full multi-tier look at everything that could be affecting performance. You may have one of the applications that's causing performance that ultimately results in poor performance with a different application. So yeah, absolutely, Diagnostic Manager is going to let you know what's going on. Even when you deal with like third-party vendors and things are running a little slow, you don't know what's going on, you pick up the phone, you call them, and they pretty much say, yeah, everything's good, it's something on your end, right? You don't have any ammunition, you don't have any information to go back to that vendor and say, no, really it is you. And that's something that the Diagnostic Manager can highlight. Hey, here's a bunch of blocking going on, and oh, by the way, they're all your queries. Or there's deadlocks, or look at this utilization that it's going on. Is there something that we can do to improve it? So again, it really just helps you with that additional information so that when you do, especially if you're not doing your own development work and you're using these third-party tools, what information you can provide them. It's just better ammunition to get better support.
All right, great, thank you. Next question, is the license for monitoring servers limited to a single domain?
It is not. And so with the licensing, let's say you buy 100 licenses, first you can choose how you want to divvy up those licenses out if you wanted to have, for example, multiple installations. If I've got very large data centers and I don't necessarily want to monitor all the instances from one location, maybe we'll divide it up. There's no additional cost for the installation itself. It's just for those license keys. The other thing is no, it's not limited to the domain. So for each of the servers, we can actually specify, let's say it's in an untrusted domain, it's a different domain, but I have access to it, I can connect to the SQL server. Well, we can monitor it, the SQL side of it, using a SQL login, and then instead of having to use WMI calls, which would require a Windows login, we can actually then use OLE automation, and we can still get query not only what's going on within SQL, we can get what's going on with the OS by using OLE automation, and we're in no way having to worry about going to an untrusted domain. We just got to be able to connect to that server, obviously, so you may have some firewall condition things to think about.
All right, great. Thank you. Next question. Can SQL DM differentiate between disk I/O slowness due to virtual machines disks problems and VM host SANs bottleneck?
Absolutely. So, for example, if you're in a VMware environment, all we need is a read-only access account into the vCenter tree. And then we can also run WMI calls and pull back metrics on what's going on in VMware. So we can see, for example, again, it's following it up the chain. We see that we have slowness with our queries. And I've actually personally worked with a couple of customers with this, where we started out, why is there all of a sudden we could see over time their queries that were taking a short amount of time were almost doubled and tripled in time they would take to execute. And as we looked up through the chain, it's like, well, it's not really SQL CPU usage that's going on. It's not OS usage going on. As we followed up the chain and we started to look at disk I/O, we could actually get information about the disk I/O that was going on with the VMware. And in their case, they had a SAN storage environment that was giving them problems, but they were able to follow up the chain and find out exactly where it was stemming from. Not that, hey, it's just performing poorly at our level. And again, another case where a lot of times you have a team that manages VMware, you have a separate team that manages the SQL side, and we see that as a DBA, hey, I'm having poor performance. We go to the VM team, we say, hey, we're not sure what's going on, can you tell me? And they may come back and say, yeah, we've looked and everything's fine. But now you have all that view of everything on one page. And now, again, it helps support, hey, I'm seeing this. We're having slow performance. We're also seeing a lot of high disk I/O or whatever it is on the VMware side. Can you look into it? And so now you're directing them, and, they don't necessarily blow you off on that.
All right, great. Thank you. It looks like we are out of questions. Thank you again to Howard and Doug for your presentations, and thank you to Idera for sponsoring today's webinar. Just a reminder, this web seminar will be available on demand starting tomorrow, so feel free to come back and review. Thank you for attending, and have a wonderful day.